Hi, and welcome to Lesson 18 in Algebra 1 Distance Learning. This is the third lesson of Week 6, and if your teacher is Ms. Boatwright, Ms. Reynolds, Mr. McCrae, Mr. Strickland, Mr. Still, or Mr. Yates, you're in the right place. I remind you can stop, rewind, or fast forward this video at any time. When you get to the end, you get to the joke of the day. If you would like to make a submission for Joke of the Day, please email it to your Algebra 1 teacher. Today's learning target is I can understand the properties of parabolas in real-life problems. We have seen about parabolas in sports, in basketball, in soccer, in football. Here's some other parabolas that we can see around us. For instance, the arc of a water fountain, or the curve of a banana. Not many of us are unaware of Mario and what he can do. How about a bridge? Here you go. Dolphins, other sea mammals, obviously always have some kind of parabolic arc to their jumps. Okay. In the parabolas around us, they would like us to answer for each of these images if the A value is positive or negative. Now, can you recall what a positive A value does for a parabola? Does that mean it opens up or it opens down? Stop the video and think about it for a minute and write down A equals opens and then up or down. Did you stop the video? I hope so. Let's take a look at this drinking fountain. It opens down, so that would make it negative. How about this bridge? We take a close look at it. Here is our parabolic arc. It opens down, so that means it's what? Negative. Banana. This is a happy banana. He's smiling for us. He opens up, so that means that banana is positive. The Mario jump, does it open up? Does it open down? If you said down, you would be correct. So it's negative. How about dolphins jumping for joy? The answer is, of course, it opens down, so it is negative. Parabolas in baseball. When a batter hits a baseball, there are two main aspects of his swing that can be analyzed: the amount of power in the bat and the angle at which the ball comes off the bat. The path of the baseball will always be a parabola, but the parabola will not always have the same equation. Baseball players who study these aspects of their swing can have better control of how high and how far the ball goes. If we take a look at this, we can see that this batter goes off at a little bit less than 45 degrees. What if you went at 45 degrees? What would happen? The answer is he would go further. What if you went at more than 45 degrees? Well, that would change the parabola, and he would probably go shorter. Parabolas in baseball. Match each graph of a baseball's path with the possible scenario. Well, let's take a look. A batter swings at a high pitch. It's a line drive, and it's caught by the shortstop. Well, this A does not look like a line drive. B could possibly be a line drive. C definitely is a line drive. And it doesn't hit the ground. So it must be what? Stop the video and see if you can match these three graphs with the three situations to the left. Hi, I hope you stopped that video and you tried yourself out on these questions. The worst thing that could happen is you get it wrong, and then you might learn one way not to do it. Anyway, our first question was: a batter swings at a high pitch. It's a line drive and it's caught by the shortstop. We can see that this pitch does not hit the ground. So, since this one over here does, we're going to go with C. The batter swings at a low pitch. It's a pop-up fly and it's caught by the pitcher. Well, A looks mostly like a pop-up, and we can see it doesn't hit the ground, so it's probably A. How about the third one? A batter hits a long fly ball that stops just inside the third base line. Well, if this is a long fly ball, it definitely hits the ground, so B is the answer for the third scenario. How about this question over here? It says something interesting. It says, some graphs show roots. Why do they not touch the x-axis? Well, how tall is a batter? Let's say 6 feet. When he swings at the ball, he probably hits it at about 3 feet. So, wouldn't hit the ball, it wouldn't hit the ground right here where he hits it. It wouldn't hit the x-axis. And if the batter's ball is caught, as it is here and here, it's not going to hit the ground either, so it still wouldn't have a root on either end. Our B scenario hits the ground, so it has at least one root. Real-life parabolas may open what? With a what A value? Or may open what with a what A value? Well, since this space up here is a little smaller, I'm going to put up, which means it must have a positive value. And then this means this is down and has a negative value. Parabolas in baseball may not have the same equation or roots. The graph will not touch the x-axis if the ball never touches the ground. What next? Hopefully you have done that great exercise in Desmos called Parabolas in Basketball. You can do practice worksheet 18. You can do homework 18. You can try the week 6 quiz. Remember, you have to do 3 assignments. Today's joke of the day. What did the duck say when he bought lipstick? The answer is, he said, put it on my bill. That's all for today. We'll see you next time.